Question 2. It takes 10 seconds for a Formula 1 car to cover 500 meters as it accelerates steadily from 3 meters per second. So again, we have an interval. What do we know about this interval? It takes 10 seconds, so that's delta t. Duration of the interval is 10 seconds long to cover 500 meters. 500 meters is a displacement, so that's the displacement for this interval as it accelerates steadily from 3 meters per second. Meters per second tells us that we're dealing with velocity. From means that its initial velocity, because it goes from that and gets more. So the initial velocity for this interval is 3 meters per second. Next step, we must determine what we're being asked. There are two parts to this question. In A, we are being asked what is the acceleration rate, and in B, we're being asked what is its velocity at the end? So end, of course, is final. So what is v final? So our next step is to choose an appropriate equation. Let's start with question A. What is its acceleration? So we're trying to find acceleration. So acceleration A has to be in the equation. So this one doesn't help us, nor does that one, but all the others have A in. So there are possibilities as far as that is concerned. But there's a second thing we need to think about, and that is it mustn't have any other unknown values in. We don't know v final, and so it doesn't help to have it in the equation. You cannot solve it if you have v final in the equation. So we cannot use that one, nor that one, nor that one. So we only have one that we can use, so let's use it. Delta x is equal to initial velocity times time duration plus half a delta t squared. Let's substitute values. Delta x is 500 meters. That's equal to the initial velocity is 3 meters per second and the duration of time is 10 seconds. Plus half, a is what we're trying to find out. Delta t is 10, and don't forget we must square it. So 500 is equal to 3 times 10 is 30 plus half a times 10 squared is 100. So we subtract 30 from both sides to clear it from the right. 500 minus 30 is equal to, 30 minus 30 is 0, so we leave it out there, plus half of 100 is 50 times a. 500 minus 30 is 470. We divide both sides by 50 to clear 50 from the right hand side. 50a divided by 50 just gives us a, and so therefore a, we can just swap the right and left behind because it's an equality. It doesn't matter which side we write it on. A is equal to 470 divided by 50, which is 9,4. The unit of acceleration is meters per second squared, not meters per second. Meters per second squared. It's a vector quantity, so it has direction. This is a positive value in the front there. We haven't written it, but it's implied, so that means in direction of motion. So we can put that value into our diagram. So we have another known variable. We answer B now. What is its velocity at the end? In other words, what's v final? So we have to have an equation which has v final in. And so this equation here doesn't help us, nor does that. The others are all fine. The next criterion is we mustn't have any unknown values. But there are no other values that are unknown. We've got v initial, a, delta t, and delta x. So we could use any of these equations that remain. And it would be a good idea for you to try answering this using all the different equations and see that you get the same answer, no matter which equation you use. Let's use this equation for now. V final is equal to v initial plus a delta t. Final velocity is what we're trying to find out. We know initial velocity is 3 meters per second plus a is 9,4 meters per second squared. Delta t is 10 seconds. 3 plus 9,4 times 10 is 94. That gives us 97. This is velocity, so the unit is meters per second. Velocity is a vector, so we must give the direction. This is a positive here. That's implied by us not writing anything. So that means in direction of motion.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!